Phoenix C&W is an independent manufacturer and supplier of chemical and mechanical products to the upstream oil and gas industry. Key products include CleanFrac friction reducer, DDrill water-based drilling fluid, and AG Bio additive for EOR. In this session, we will be focusing on green, low-cost additives for high-performing water-based drilling fluid. This is a series of additives under the trademark of DDrill and differ in application temperatures. As was stated in the title, these additives are environmentally friendly, cost-effective, and multifunctional, with advantages over microfracture blocking, shale inhibition, and filtrate control. The highest application temperature is around 200 degrees Celsius or 400 degrees Fahrenheit. In contrast, all the known counterparts perform only up to 150 degrees Celsius or 300 degrees Fahrenheit and are cost prohibitive. More details will be coming up next. 3 additives are available. They are DDrill 200, DDrill 300, and DDrill 400. DDrill 200 targets the application temperature of 200 degrees Fahrenheit or 110 degrees Celsius. DDrill 300 works up to 300 degrees Fahrenheit or 150 degrees Celsius, and DDrill 400 is applicable at 400 degrees Fahrenheit or 200 degrees Celsius. What are the key features for DDrill? Basically, DDrill additives are environmentally friendly and high temperature applicable at low dosages. They are based upon nanoscale structures for multiple functionalities in terms of rheology, fracture blockage, filtration control, and calcium tolerance. Normally, the overall dosages are less than 5%. In the case of DDrill 200, it is readily applicable upon mixing with brine and weighting agent. In the cases of DDrill 300 and 400, additional ingredients such as bentonite and thinner may be needed to generate field-feasible water-based drilling fluid. The upcoming 2 slides will be focused on the current situations with using oil-based mud, or OBM, and water-based mud, or WBM. It should be noted that the current trend is to replace OBM with WBM due to HSE and cost issues. Diesel is frequently used in OBM as the carrying fluid. However, it is toxic and cost-inhibitive. The use of OBM often requires the use of dosages greater than 10% and inflict performance issues such as rate of penetration, ROP. Low-cost and green WBM are highly sought after in the oil and gas industry. However, the current WBM are dominated by expensive additives that work only up to 150 degrees Celsius or 300 degrees Fahrenheit. One may have to resort to environmentally unfriendly sulfonate-containing systems to tackle high temperatures. Moreover, the use of these non-green components often exceeds a dosage of 10%. DDrills are composed of basically 3 categories of functional materials. They are, number 1, broad-spectrum brine-tolerant rheology modifier to realize suspending and shear thinning. Number 2, internal shale inhibiting component to mitigate shale instability issues. The use of heavy brine is recommended for additional shale control. Number 3, nanoscale structures toward fracture blockage, damage minimization, and filtration control. This slide shows the appearance of DDrill 400, which is snow white fine powder. Both DDrill 200 and 300 have similar appearances. When following the reference formulations provided in our technical data sheets, the filter cakes after static fluid loss experiments are expected to be less than 1 mm thick, which is demonstrated on the right side of this slide. It was found that the use of DDrill led to shale recovery of greater than 90% and linear shale swelling of about 1.5%, which is slightly higher than that by oil-based mud. It should be emphasized that each shale is different. Therefore, shale-specific evaluation is recommended to render peace of mind before application. Also, DDrill is designed not only for drilling shale, but also conventional and geothermal wells. In each different scenario, it is recommended the reference formulations to be further tuned to target specific concerns or situations. The table on this slide demonstrates the rheology and fluid loss control properties by DDrill 400 before and after aging at 400 degrees Fahrenheit or 200 degrees Celsius for 16 hours. The mud was shown to be able to maintain its rheology after hot rolling, and the fluid loss was even somewhat lower than that before hot rolling. A major motivation to utilize WBM is to address environmental concerns. In this regard, it is desired to have minimized organic matter in water to mitigate pollution. Two parameters are frequently adopted to characterize the extent of pollution. They are COD and BOD. COD stands for chemical oxygen demand, which is an indicative measure of the amount of oxygen that is to be consumed by reactions in a measured solution. BOD, which is biochemical oxygen demand, is the amount of dissolved oxygen needed by aerobic biological organisms to break down organic matter present. The lower the COD and BOD, the lesser the extent of pollution. DDrill can be substantially separated by centrifugation from water. Thus, both COD and BOD will be minimized. One other toxicity parameter is EC50. EC50 refers to the concentration of a chemical at which half the population of the testing fluorescent bacteria is killed. The higher the EC50, the lower the toxicity. EC50 for DDrill was evaluated to be greater than 1,000,000 ppm, which means that it is greener than our drinking water from the perspective of EC50. In contrast, the EC50 for a regular sulfonate containing WBM was 895 ppm, confirming its toxic nature. Anyways, don't miss out on the opportunity of taking advantage of these game-changing DDrill additives for water-based mud. We, Phoenix C&W, and the team behind it will strive our best for your every success. For more information, please visit our website at www.phoenixcnw.com or contact us by email or phone for a free consultation. Thank you.